السلام عليكم أصدقائي الطلاب. Welcome to Chemistry Online with Mr. Ahmed Sulaiman. Today we are going to start new chapter, Oxidation, Reduction, Reactions. The first lesson is the meaning of oxidation and reduction. What is meant by oxidation and what is meant by reduction? What are oxidation and reduction? It happens to some substances, oxidation and reduction. The substance that oxidized, the other substance reduced. It means there are two processes at the same time with two substances. No oxidation alone, no reduction alone. Let's first understand or recognize what is meant by oxidation and reduction. You know, combustion of gasoline, which is using in cars, automobile engine, or burning wood, burning paper, all of these processes are oxidation. Why? No burning or combustion without reaction with oxygen. Substance reacts with oxygen and burns. No burning without oxygen, reaction with oxygen. So combustion or burning means reaction with oxygen and produce carbon dioxide, water vapor, whatever. But this is the meaning of oxidation. So burning or combustion means oxidation. What happened to this substance? It gains oxygen and burns. So gaining oxygen means oxidation happens. Oxidation process happens. So the reactions that require oxygen or need oxygen and release energy because it's burning, it means oxidation. Also, we have some other examples like breaking down food inside your body. It releases energy, and before releasing energy, it reacts with oxygen you are breathing. So it's a type of oxidation as well. Any burning or a combustion releases energy, like food, like gasoline, like wood, like anything. Okay, and we are using this oxygen to burn the food and get energy after breathing, when you breathe. We need to understand more in the case of reaction, real reaction. Look at this example. First, the oxygen reacts with substance and produce some products, and this reaction at this moment, if oxidation happens and also reduction, as I said, because no oxidation alone, at this moment we call the reaction redox. Redox means reduction oxidation process. So simply we called it redox reaction. Reduction, oxidation. If we have methane gas, like this, molecules of methane, it reacts with oxygen. Oxygen molecules, it means we are burning them. You know, methane gas is the main component of natural gas. About 94% or more of natural gas is methane. If it burns with oxygen, reacts with oxygen means burning, it produces carbon dioxide and water vapor gases. What happened to methane here? It changes into CO2. CH4 changes into CO2. What happens? Look and pay attention. It gains oxygen. Oxygen replaces hydrogen and becomes CO2. So methane gains oxygen, means oxidized. You know, we have two meanings of oxidation here. If the substance gains oxygen, or if it releases or loses hydrogen. Both have a meaning of oxidation, you know. That's what happened here. CH4, what happens? It loses hydrogen, it means oxidation, and it gains oxygen, it means it oxidizes as well. Okay, so we have oxidation process here. What happened to oxygen? Oxygen moves to methane and changes into water. What happened to oxygen? Changes into water. It gains hydrogen. It becomes from O2 and now H2O. So it gains hydrogen. The opposite of this process. So gaining hydrogen, or we can say losing oxygen, means reduction. Don't forget that. An example of burning methane gas, like this flame, for example. Not all of the oxidation process involve burning. I give you examples of burning by using oxygen, yes, and this process called oxidation, but not all of them are burning. Not all of the reactions with oxygen means burning. Like this reaction, if you have iron reacts with oxygen molecules very slowly and it becomes iron 3 oxide. Iron 3 oxide is a compound of rust. But look, it reacts with oxygen. It's not burning, but we called it oxidation. Yes, it's a process of oxidation. But the difference between this process of oxidation and the previous oxidation is speed. Burning is very fast. Just burn. It happens, the reaction happens, okay? But here, it's very slowly. To make some iron rusting, it needs 1, 2, 3 years, 4 years, like this. It's very slowly process, but it's oxidation as well. The process opposite to oxidation is reduction. It's opposite of oxidation. Reduction means, as I said, loss of oxygen from a compound, or sometimes gaining of hydrogen. This is the meaning of reduction. The reaction of oxidation and reduction at the same time must be at the same time. It happens at the same time. Called redox, I told you that. We have an example here. We need to understand this and we need to identify what happens to each of these compounds. We have iron 3 oxide changes into iron. What happens here? It loses oxygen. It means it's oxidized or reduced. It loses oxygen. It means it's reduced, yes. What happened to carbon? Changes into carbon dioxide. What happens here? It gains oxygen. It means it's oxidized. So from this reaction, we can conclude that reduction and oxidation happens at the same time in the same reaction. But look, not all reactions in chemistry must have reduction and oxidation. Some other reactions don't have. But if the reaction has oxidation, it means it has reduction. Must be. It's a must. Because both are happening at the same time. No oxidation alone no reduction alone. So from this reaction we got that iron 3 oxide is reduced to iron by losing oxygen, carbon oxidized to carbon dioxide by gaining oxygen. So we can say this process included in this reaction, iron 3 oxide reduced and carbon oxidized. It means oxidation, reduction, always happens at the same time, both of them. If you have a substance undergoes oxidation, it means it gains oxygen. If you have substance undergoes reduction, it means it loses oxygen. Or we can say oxidation means gaining oxygen or losing hydrogen sometimes. And reduction means loses oxygen of the substance or gaining hydrogen. As I said, no oxidation alone. No oxidation occurs without reduction, and no reduction occurs without oxidation. If you have reaction of oxidation and reduction, so we called it redox reaction, I told you, we have a new meaning of oxidation and reduction or redox reaction. Why new meaning? Because the scientists found that some reactions like redox reaction, it means oxidation happens, reduction happens without existing of oxygen or hydrogen. You remember Lewis' theory of acid and base? The same idea. Some compounds don't have oxygen or hydrogen, no gaining, no losing hydrogen or oxygen, but redox reaction happens. So we have to use electron shift in the redox reaction to understand the meaning of this type of reaction. Modern concept of oxidation and reduction have been extended to include what? The reaction that don't even involve oxygen. At this moment we explain it by using electron theory between the reactants, transferring electrons. Look at this. What is meant by oxidation here? If complete or partial loss of electrons, it means oxidation, or as we said, gain of oxygen. So we know gain of oxygen means oxidation, but the modern meaning here is losing electrons. So if you have a substance, element, or molecule or compound, and it loses electrons, it means oxidation. Don't forget. The opposite for reduction, complete or partial gain of electrons, it's reduction, like loss of oxygen. So if you have substance and it gains electron, it means reduction. So we have meanings now. Oxidation means loss of electrons or gaining of oxygen. Don't confuse losing electrons or gaining oxygen, whether this or that means oxidation. But reduction means gaining of electrons, the opposite, and losing oxygen. So gaining electrons or losing oxygen means reduction. This is two meanings we got up till now. Let's see this example to understand how can we find like this reaction without oxygen or hydrogen in the reaction, but it's a redox reaction. Look at this. Magnesium is an element, metal, and sulfur is non-metal, solid. If you react both of them together by heat, it produces magnesium sulfide. What happens here? Look, magnesium has 2 valence electrons. You remember that? Okay. And sulfur has valence electrons 6. 1, 2, 3, 4, 5, 6. It needs 2 to complete the last level by 8. You remember? Octet rule. It gains these 2 electrons from magnesium. So, magnesium loses electrons and it changes into Mg positive 2 in the compound. The compound is Mgs, yes. If you remember, how can we identify the charges of each in the compound? Mg is positive 2 and sulfur is negative 2. So what happened to Mg here? Mg element changes into Mg positive 2. It means it loses electrons. It means it's oxidized. Yes. And sulfur, what happens here? It gains, it changes into negative 2, sulfur negative 2 in the compound. It means it gains electrons. Gaining electrons means reduction. You understand? So the process here is magnesium oxidized, I told you, because it loses electrons, pair of electron to sulfur, and sulfur gains these 2 electrons and it reduced, change into sulfide. No oxygen here, no hydrogen here, but this reaction redox reaction. We can do something and we have to learn this. In this reaction we have magnesium. What happens? Again, oxidized. What happened to sulfur? Reduced. It means oxidation happens to magnesium and change into Mg positive 2 and it loses 2 electrons. We can write this half equation. We called it half equation and we called it oxidation process only. Look, oxidation here, magnesium loses 2 electrons and changes into Mg positive 2. What happens here? Loss of electrons. This is the oxidation half of oxidation reaction. What about the reduction reaction? Sulfur changes into sulfur negative 2. What happens? It gains electron. Look, sulfur element gains 2 electrons plus 2 electrons and changes into sulfur negative 2. It gains electrons. So this reaction is reduction. What happens here? We divide the reaction of redox into 2 reactions. Reaction, oxidation, and reduction, each alone. This is redox reaction. The substance that undergoes the oxidation loses electron at this time, not gaining oxygen, and undergoes reduction, gains electrons, not losing oxygen at this moment. Don't confuse, please. What happened to the substance that oxidized? We called it reducing agent. What happened to the substance that reduced? We called it oxidizing agent. Look, we are talking about not the process oxidation or reduction, but the name of the substance, reducing agent or oxidizing agent. What does it mean? Let's move to this reaction again to understand. Again, what happened to magnesium here? Oxidized. So the process called oxidation. Yes, we call this substance, what happens is oxidized, but the substance is reducing agent. Reducing agent. Why? Because it reduces the other substance. What happens to it? Oxidized. But what did it do? It reduces other substance. So we call it reducing agent. طب what about sulfur? What happened to sulfur? Reduced. Yes, it reduced. The process is reduction. It reduces. But to be reduced, it is the cause of oxidation of the other substance. That means we called it oxidizing agent. You understand now? So the substance that loses electrons called reducing agent, and the process of it is oxidation. The substance that gains electrons called oxidizing agent, as I said. So what's meant by reducing agent again? Substance that loses electrons in the reaction. It's a reducing agent like Mg. The substance that accepts or gains electrons, we called it oxidizing agent like sulfur. You got that? Look, magnesium and sulfur. Magnesium oxidized here, as I said, so it's reducing agent. Sulfur reduced because it gains electrons, so it's oxidizing agent. This is the meaning of oxidizing agent, reducing agent. We have example here. We need to explain and answer together. Look, we have silver nitrate reacts with copper element solid, yields copper 2 nitrate and silver. What happened to each of them? Where is the oxidizing agent? Where is the reducing agent? And what happens to AgNO3? Oxidation or reduction? And what happens to copper? Oxidation or reduction? We need to identify all of that. What is oxidized? What is reduced? And also we need to identify the oxidizing agent and the reducing agent. First, we'll make the ions alone to identify what happens to each of them. AgNO3 divided into Ag and NO3, and because the coefficient is 2, so 2Ag and 2NO3. Copper is solid metal. Copper has charge 0, no charges here. But here -1 and here +1, as you know. What happens to silver first? It was +1 and becomes 0. What happens to silver? It gains electrons or loses electrons? Look, it was Ag +2 and becomes a neutral, Ag only, silver solid. It means it gains electron. Gains electron, but they are 2, so it gains 2 electrons. Okay, it gains electron. What does it mean? If it gains electron, it's oxidized or reduced? It gains means reduced. What happens to copper? It was 0 and changes into +2 ion, because CuNO3 by 2 means copper +2. So what happens to copper here? It was 0 and changes into +2. It means it loses electrons because it changes into positive. So electrons lost. Simple meaning. Electron lost means it loses electrons, means oxidized. The substance that reduced called oxidizing agent. The substance that oxidized called this copper is reducing agent. You understand? So easy, I guess. So the electrons lost from copper here, as I said, so it becomes positive 2. These electrons gained by silver and becomes neutral silver. Because of that, we can say the species that lose electrons is oxidized, and we called it this substance reducing agent. The species that gains electrons reduced and called it oxidizing agent. And we can write these two reactions individually. Oxidation happens to copper, so copper yields copper positive 2 plus 2 electrons. It releases electrons or lose electrons. Reduction here, gain electrons like silver, gains 2 electrons and becomes silver metal. So copper is oxidized and we called it reducing agent. Silver is reduced and the substance called oxidizing agent. This is our lesson and this is part 1 of 20.1. Thank you, Shabab.